You're the next speaker. Great. Tiled, is it?
Yes.
Yes. Okay. Over to you.
Thank you very much. Hi, I'm Dylan McReynolds. I lead the data management team at the Advanced Light Source at Lawrence Berkeley Lab. And I am not an AI ML expert. What really excites me is application development, system integration, databases, things like that. But like most people in my field, we're dealing with a lot of new AI ML type integrations, and I wanted to give a talk about excuse me, about some of the work. Thank you. About some of the recent work that we have working on. Before I get to the work itself, I just wanted to introduce Tiled. Tiled is a tool out of the Blue Sky framework, or the Blue Sky ecosystem. It is a data service that allows you to search on metadata, slice into remote data sets, transcode between formats, which means Tiled you can introduce different file types to Tiled that it has access to, but it will provide over HTTP a more regular data model. So the Python Tiled client, for example, speaks regular SciPy style, or SciPy APIs like NumPy and Pandas and X-Ray. You can download partial or whole data sets. So we think it's ideal for system integration type scenarios where you don't want applications where you don't want to have to download an entire tomography reconstruction. You might want to download just a slice at a time, and we can do that over HTTP with Tiled. And again, it's HTTP, so it implements very standard web securities protocols and optimizations, or authorization. I'm not going to go too far into Tiled, but I wanted to invite you to Dan Allen's talk on Thursday called Tiled in the Context of Data Management Services, where he's going to go into a lot more detail about the system. As I said, Tiled can serve Tiled's Python API, which we see on the top left, has a fairly easy API to get at data and get data in NumPy arrays or Panda data frames. Being an HTTP server, it is sort of naturally fits in a lot of integration scenarios, and can serve data for a number of clients. On the bottom right here, we see an application developed in Igor by Elliot Gann at NSLS2, which sort of was a proof of concept that we can use Tiled to provide data to a variety of different languages and frameworks. And it comes with a very nice web application that lets you browse through your data and do some very simple visualizations. One of the things that you might notice here is that Tiled automatically does some transcoding between the native format, whether it was in TIFF files or HEFI files, and provides if requested, can provide web-friendly formats. So it does the decoding or transformation over in real time. I wanted to talk just briefly a little bit about the history of Tiled. That again, it comes out of the Blue Sky ecosystem, where in the past, the original framework for getting at your data in Blue Sky is called Data Broker, in past and present, and it's a Python library for data analysis and access. But it has a little bit of a limitation in that it is the Python client has to be located fairly closely to the Mongo database that's backing it and the file system. There's no real remote capability in it. Tiled was dreamed up as a way to provide that same API over HTTP with web-friendly protocols, which lends itself to a whole variety of system integration applications that we think. It's ideal for browser-based applications, and as I said before, has a Python client for accessing data, which itself talks over HTTP, but relevant for the rest of this talk, it's not Tiled is not necessarily tied to Blue Sky's control system. It can be used on its own for other purposes. Switching gears really quickly, we heard a little bit about some of these multi-facility AI ML projects that are going on. We at the ALS are involved in, along with APS, NSLS2, and Slack, in the ML Exchange project, whose main goal is to build a suite of applications that can that make it easy for people who are not experts in AI and ML to train models, use models, test models, and provide their models to other collaborators. Don't worry, I have a much simpler diagram in a later slide. But one of the major focuses of the ML project is to try and integrate some of the applications directly at the Beamline and make them available for Beamline users. A few of the example applications that we can talk about. On the top left, we have a thing called Label Maker, which uses a model that's trained to recognize features to assist in the manual categorization of images. So if you have an image that you've categorized as having rings, the Label Maker can give you provide a search on the nearest neighbor search on the latent space of the trained model, provide you with a variety with a number of similar images so that the user can then say, yes, all of these have that particular feature, and just to try to speed up the very laborious act of doing categorization over a lot of images. On the right, we have a tomography or image segmentation project that I'm going to talk about a little bit more. What we're seeing, the goal of this is to take a reconstructed tomography image, provide a easy-to-use web-based annotation tool, train a model from scratch on using just a few of the segmented the images that the user segmented, and then run a number of models that we can select from to then be able to segment the entire data set. Furthermore, we think it's really interesting to provide pre-trained models from different instruments to be able to see if we can use a model that was trained on images from one instrument and use it for inference at another. Again, these are all, the ML Exchange stack is all web-based. We use several tools to manage and create the user interface, like Prefect for workflow management, the Dash framework from Plotly for building fairly quickly building user interfaces, PyTorch and TensorFlow. And the project has been going on for a number of years, and we are recently transitioning to using Tiled as a backing service to get data in and out of these applications. I'm going to have to skip a little bit, but the browser application for segmentation, for example, sends messages to a prefect server, which we're using almost like a queuing service, where but the workers that do the processing can be located anywhere on any machine as long as it has HTTP access back to the prefect server. We're using a tool called Delcia, which was developed by Peter Zwart at Camera, which is a PyTorch-based API that comes with a few model types and makes it fairly easy for a user to input the hyperparameter, create different flavors of model with the hyperparameters, and not having to do all of the legwork of figuring out how to get a UNet or a multi-scale dense network going. And Tiled as the data service. Okay. What happened to that slide? Okay, some slide problems, interesting. Where are we? There we go. I've already sort of covered this, but the point I wanted to make here is that in this application, we're using Tile to serve reconstructed images to the user application, and store and serve masks that the user creates with their classification, and also serve the segmented reconstruction. This is basically what I just said, and we recently had an opportunity to integrate this framework directly at a beamline at Diamond, at the Dyad beamline diffraction imaging beamline run by, we were invited by Sharif Ahmed to come take our whole system, install it right at the beamline, integrate with their reconstruction framework so that as we were doing scans, reconstructions were happening. When they were finished, we got notified, and the user was able to quickly see that in our application and run the segmentation. 2 minutes left. Okay, just wanted to make, well, actually, with the time, I'm going to skip. Another application that we've used in this framework that uses Tiled is something we call the Latent Space Explorer, where we can provide a trained autoencoder on a full data set. For example, in this image, we see a time-resolved GSAX data set for an in situ scan. And then the application clusters. Oh, sorry. The application clusters those, each image and displays the image, the clustered image, and lets the user explore over the whole set where those clusters exist. So you highlight one of the clusters the image shows. For this, we're using Tiled to serve data for inference and to store and serve the feature vectors that the autoencoder comes up with for that data set. Some future work. this framework right now is sort of available on a friends and family basis, where we can deliver it right to a Beamline and not really worry too much about authentication. But we really Tiled itself has a very rich authentication framework in it, and we see the need, if we're going to build it out for bigger audiences, we need to do something like make use of a gateway, API gateway, to handle the authentication and let the backing services sort of do their thing without having to individually handle authentication. I saw MLflow in the first talk, and that's something that we're very interested in integrating into this for tracking and managing all of the different assets that we have to deal with in these ML workflows, and different types of prefect workers. I didn't have time to really go into that, but there are a lot of different places that we want to run training and inference, and there's a fair amount of work to be able to seamlessly provide the access to those within prefect, and that's a thing that we're really interested in doing. I just want to acknowledge that I showed work from a whole lot of people from a whole lot of facilities, so thank you very much.
Yeah, thank you. Okay. Made it in time. Yeah.